Hello Year 4, this is your science lesson for today. As you know, both classes have been looking at electricity and we've looked so far at how we get electricity and the two main types of electricity we use being mains and battery. But today we're actually going to be constructing electrical circuits. So you can see from this page that our want is to construct a simple electrical circuit, and we're going to identify complete and incomplete circuits. Now, those of you in my class know that I have some resources in the classroom that we were going to use, but don't you worry, because we'll use those when we get back, and I have actually found a really cool website for us to use today. So our steps to success, we're going to be setting up a circuit today. You're going to be identifying what makes a circuit complete and recognizing a complete and incomplete circuit. So, do you know what a simple electrical circuit is? That's my first question for you today. What do you think they will look like? What do you think an incomplete one will look like? What do you think a complete circuit will look like? Okay, these are questions for you to think of at the moment. I don't expect you to know the answer. And if I just move the learning pit down for you so you can see, where would you think you are on the learning pit at the moment for this lesson? Do you already know loads about circuits? Have you used them before in school? Do you not know what a circuit is? And that's fine as well. So maybe have a think where you would be at the moment, and hopefully by the end of this lesson, you will be much further along. Okay. This is what I mean by a circuit. These wires, bulbs, batteries, things like that. So I've got two pictures here for you. What is the same? What is different? And have a look at both of them. So on the left, I don't know. I don't want to tell you what they are at the moment, but I've got a left picture, bulbs, wires, batteries, and there's a switch, and there's a one on the right. So think about what's the same and what's different in them both. Think about what you already know, and would there only be one answer? And of course, there is no true answer. There's no correct answer to this. It's just, what do you think? Okay, so I'm going to talk to you a little bit about circuits because they can be both complete and incomplete. The current electricity is the flow of electrical charge through materials. So therefore, every complete circuit must have a power supply. And the power supply could be the mains, or it could be a battery. And remember, we've spoken quite a lot about those two things in the last 2 weeks. For a circuit to be complete, however, there must be wires connected to both the positive and negative ends of the power supply. And electricity can only flow around a complete circuit that has no gaps. That's the same with a battery and the ones that we're going to be looking at today, or the same in your houses. So is this circuit complete or incomplete, and how do you know? So over here on the left, we have a circuit made up of a battery. So this is the battery here, and we have a switch here, and we have a bulb here. And all of these are wires. So we've got a blue wire, a red wire, and a black wire. And these are connected to the appropriate ends using crocodile clips. So those are the pinches. So do you think it's complete and incomplete? Having a look at that diagram. And I'm just going to move away some of the drawing I've just done on there. Do you think it's complete or incomplete? Okay, this circuit is incomplete because there is a gap in the circuit. So the electrical current cannot flow around it. So there is nothing connecting to this end of the battery. And we know from the previous page that it has to be both ends of a battery. So there's nothing able to flow through it. And the wires do not connect to the positive and negative ends. So it's this part here. So if one of our wires moved, it might have been complete, but this is incomplete and this will not work. The power supply from the battery cannot travel around the wires to light the light bulb. Okay, let's have a look at another one. This is the second one. Do you think this is a complete or incomplete circuit, and how do you know? So again, we've got the same pieces of equipment. We've still got our battery, still got our switch, and still got a bulb, and there are some wires going around it. Hopefully you will have noticed that this is a complete circuit. There is a power supply, so that's number one, the battery. There are no gaps anywhere, so the electrical current can flow around the entire circuit. And the wire connects to both the positive and the negative ends of the battery, so from both ends. Okay, so today you're going to make some predictions on whether you think a circuit is complete and incomplete, and then you will test them. And remember, even though I'm not going to be able to give you the wires and the bulbs and things that I have ready in the classroom, I have found that cool website that's going to let you do the same. Having a look at this circuit here then, what would your prediction be of this circuit? Have a look where the wires are connecting on this image, have a look at the battery and have a look at the bulb. It also says at the bottom, if you think it's incomplete, what is the error? So you can pause the video here, write down your jotting if you would like to, or just have a think about whether it's complete or incomplete and how you know. Okay, well done to those of you who said it's incomplete. We can see that there is a gap from the bottom end here of the battery, and the wire has not connected to both that negative and positive end. So we know it's incomplete. That was our prediction. And if we think it's incomplete, what was the error? The error is that this wire has not gone to both ends of our battery, both ends of our power supply. Okay, Emmett here. I think that a circuit will always be complete if it has a power source, something to power, a light, a buzzer, etc., and wires that are joined up. Emmett thinks that a circuit is complete if it contains the elements that are joined up. Do you agree or disagree with Emmett, and why? Hopefully it'll be similar to your answer from the previous page. Okay, just something to think about. This is therefore our activity from today, and your task is going to be to make some predictions as to whether a circuit is complete or incomplete. And you will notice that this first one on your sheet is the one that we have just done together. So you would write prediction complete or incomplete. So I think this is incomplete, and you will be able to make that a lot smaller to fit inside that box. It would also help if I spelled incomplete properly, and I would need to just make that a little bit smaller. So I think that's incomplete. This is the first stage. You'll then have a look at the next one. Do you think this is complete or incomplete, and why? So you could make another prediction and pop that in the box. And you would have a go all the way down, changing to complete or incomplete, depending on what you thought. But I'm not going to give you the answers. The first task before you do anything else is to make that prediction in all of those 4 boxes and really have a look at the pictures that is bigger on your sheet as well. Then comes the fun part. On Go Deep over here, it says, once you have made all of your prediction, you will then need to test the circuits, and you will be using that link. So I mentioned that cool website already. I am going to show you what that looks like. So I will make sure that you can see the link, but I actually have it that I can show you the link on the computer now. Okay, when you click on that link, you will be given a page that looks like this. Now, this is just on the internet, and we're going to go into the intro first of all. So on the left, you can see wires that you can drag out, batteries, bulbs, and so on. And there is an arrow of different things that you could be using on here, as well as pencils, erasers, things like that. Now, our first one, if we remember, had a wire and a battery, and it can, without turning that too much, it had a wire that connected from the battery on one end, and you can see it does click there quite nicely together, and it had another wire doing the same thing. I'm just going to go back and check. So it went from the other side of the bulb, and it actually went back to that same end. Now, it's not liking to connect, because we know already that a light bulb will need to be charged through both ends of the battery. And you can see what happens if I pop that on. So you can see the animation speed is there, the battery's gone straight through it using the wire. So I'm going to restart that one. So I'm going to take another wire and a battery and a bulb out, and I'm going to take 2 wires. One from one end and 1 from another. Okay, so you can see that happening there. This button here at the bottom means that you can reset. So then you'll be able to check another one. And you can take batteries, wires, you can take a switch, for some of them might need one, and you'll need a few wires to connect all the way through. Okay, so you can see that when it lights up. Now I've just realized I made an error, and you noticed, and I was wondering why, when we had our battery and our light bulb out, first of all, there are 2 points that you can connect to. So I tried to connect my battery and my wire to the same point, and you'd have noticed that it didn't work there. So that's from my same end. But there are 2 different points on each of the batteries and 2 different points on the bulb. So you can see there's a grey circle here and a grey circle down here. So if I pull out my second one, just redoing this first one again, and make sure I connect 1 to that end and 1 to that end, you'll notice now that there isn't that fire symbol because I haven't short-circuited it, and you can see that it does work, and you can see that energy flowing through. I am quite new to that website and that link, and hopefully you'll be able to experiment a little bit with it as well. But I'm just going to come back here to the notebook then, because once you've done that, it will ask you to explain what happened. So going back to that go deep, you need to test it. Was your prediction correct? So we predicted that it was incomplete first of all, and yes, my prediction was correct because it was incomplete, and we need to then explain why. So over on this right hand box, it was incomplete because ... Now I'm not going to give you the answer, but remember we spoke about making sure the wires connected to both the positive and the negative ends of the battery. And again, yours would look a lot nicer because you can write straight into that box. Okay, this bit here, what I've just done with you, is explaining the errors. And if you need to think about why it didn't work or how you could fix them, you could pop that into the box as well. I really hope you enjoyed having a go with that website. Like I said, I'm quite new to it, and you saw that mine even went on fire because I hadn't connected the wires up. But it's a really good chance for you to have a go using a website that would do the same as the things that we would be doing in school with actual wires. We wouldn't make fires in school though, it just wouldn't work. And when we come back to school, you'll be able to do it with the real life equipment. Before I leave you to have a go at that, or if you've come back after you've had a go, just have a think about the working scientifically skill that we focused on today. Did you set up practical inquiries and do a fair test? Did you identify similarities, differences, changes? Did you gather, record, classify, and present data? Did you use scientific evidence to answer questions? Did you use results and draw conclusions and make predictions? Did you ask relevant questions and use scientific inquiry to answer them? Did you make observations and take accurate measurements? Did you record findings using scientific language, diagrams, drawings, or did you report findings from inquiries? Now, I think there was possibly 2 that we dabbled into, but you can have a think of which ones you think we worked at. I really do hope you enjoy the science for today and enjoy that link. I will make sure I pop it onto the sheet and onto the daily posting for you. Good luck with it, and make sure you send me or Mrs. Cross, Mrs. Plews, a photo of what you've been up to and whether your predictions were correct or not. Well done, guys. See you then. Bye.